Alright, so before we move on to talk about deep learning, I'd like to provide you with a brief history about the neural nets as well as deep learning development in the past years. So actually, the deep learning has been developing for so many years, since the 1950s. So in 1950, Turing described how learning could be a path to achieve machine intelligence. So he just proposed some ideas about how the learning can be a way to achieve the artificial intelligence with machines, right? And then after that, many people have been proposing different ways to do these kinds of things for us. And one of the methods was proposed by Rosenblatt. He proposed a new model. It's called perception. And we will talk about the perception later. The perception model is so simple, and it has one single layer. Give the input, it can project the input to the output via both linearly as well as one activation function. And Rosenblatt proposes perception can be used as a model to address the classification task, and we can differentiate different kinds of inputs, and then we can build a model which achieves this kinds of classification purposes to this task. And then we can propose a model to address the classification task for us as one of the practical learning methods. This perception seems to be unpromising. However, this direction has been killed generally by Minsky by his book. In 1969, Minsky has published one textbook describing the fundamental limitations of neural networks. He points out that the perception model cannot do a very simple classification task on the XOR dataset. In other words, this kind of perception cannot address this nonlinear separation task, which is so simple task actually in many cases. So this textbook generally killed this direction on the studies on perception. So in many years, you can see, this direction or the neural network direction has been dying for more than 10 years after Minsky's textbook was published. So, because in that year, we don't have the idea of deep learning yet, and most of people are just starting the perception with just two layers, the input layer and output layer. And at that time, we'll just focus on the channel learning with no hidden layers at all. And after this area has been dying for more than 10 years, then we have some people propose to we can add some hidden layers into the perception model to make it handle the nonlinear separation tasks. However, when we have the hidden layers, we will also need to have some new algorithm for training them, right? And then in 1986, the Hinton, if you know that. And then in the 1986, Jeffrey Hinton, he proposes the error propagation algorithm as a practical method for training deep nets. And with this error propagation algorithm, then the research on the perception models resumes, and many researchers propose to add some hidden layers into the perception to make it deeper, and it can address many of the more complex classification tasks with nonlinear cases. So this error propagation algorithm was proposed by Jeffrey Hinton, and he is also the Turing Award winner in the 2018, right, in the previous years. And we also have a new algorithm proposed in 1989, which is called neural net. And many people also call this one as CNN, right? Convolutional neural nets. Actually, this neural net was proposed by Yannick. He is also the Turing Award winner in the 2018, right? Together with Jeffrey Hinton. So CNN model actually was proposed more than 30 years ago. So you can see that neural net or the CNN model actually was proposed more than 30 years ago, but right now it is still used by many of the industry as well in the research papers nowadays. However, after the proposal of this error propagation algorithm as well as neural net, actually didn't receive much attention from the community because the community has been, the attention has been focused on the classic machine learning areas. And we have a huge wave of interest in machine learning community in the probabilistic methods, convex optimization, but most in channel models. And not much attention has been devoted to the neural nets or deep learning models. The main reason is because there is no physical meaning for the representation learned by these models. It is very hard to interpret the learning process as well as results by these deep models. And during these years, almost all the proposals submitted by the researchers to NSF, they get rejected because there is no way to interpret the learning process in the deep models compared with classic machine learning models. And almost all the papers submitted to the conferences or journals, they get rejected either because it is very hard to explain the learning process. So this area has also been dying for more than 10 years again, during these years because of the lack of interpretations about the learning process as well as physical meanings about the learning results. So people have been devoting their attention as well as focus efforts to the classical machine learning community and to work on models like SVM or the probabilistic graphic models and some other areas. And after many years, in 2006, the deep neural nets start to gain more attention again. The main reason is because we have more data. And during this year, we have been collecting more and more data, and we have a concept of the big data coming out. And also, due to the development of the hardware as well as chips, and we can have GPUs to help us train the very complex models. With data, with GPUs, as well as new algorithms, then the deep learning models start to gain attention again. And in 2012, the Crash Haskell's NXNet paper beats all other methods on the ImageNet for the object detection and recognition compared with the classical methods. Then, the deep learning model becomes one of the hottest topics in the community, and many people start to work on this area until now. So you can see in the history for the artificial neural nets as well as deep learning, we can see the ups and downs of deep learning during these years. From the very beginning until the perception, we are going up, and then due to Minsky's book, then we go down, and has been dying for more than 10 years. And then some people start to work on this area by proposing hidden layers as well as the error propagation algorithm for trained deep learning models, and we also have no net or the CM model proposed. However, due to the limitation in the interpretation as well as physical meanings of the learning results, the area is going down again. And then in recent years, due to the development of big data as well as chips and GPUs, people start to work on complex models again, and the deep learning has been also one of the mainstream tasks started in the community. And for the future, will it still go up or it will go down again? We have no idea. And I just want to provide you with the history about development of this area. It will be much better for you when you are taking this course and also doing research in this area. And you may wonder what happens during these years from the publication of Minsky's textbook until the current surge of deep learning. And this course will provide you with all these models proposed during these years for you. Okay, so this is a history for deep learning development in the past years. You know the history, and you can also take it as a guidance for you when you decide to work on some domains.